Hey everyone, and welcome to this explainer. Today, we're going to strip right past the marketing fluff and look at the actual, undeniable mechanics of how internet privacy works. If you've ever seen an ad promising that some piece of software is going to make you a total digital ghost, well, you might be wondering what's real and what's just clever sales copy. We're going to break down exactly what virtual private networks, or VPNs, actually do, how they fundamentally change the way your data travels, and, maybe most importantly, what they absolutely cannot do. Quickly, here's our roadmap for today. We'll kick things off with normal browsing, then introduce the VPN double envelope concept and get into who actually sees your data. After that, we'll take a deep dive into tunneling and DNS, bust a few persistent industry myths, and finally pinpoint exactly when you really should be using a VPN. Let's pull back the curtain on this whole thing. Okay, Section 1, normal browsing. Let's dive right into this and look at the reality of our everyday connections. So here is the fundamental question. When you're just sitting on your couch, you open your laptop and type in a web address, you feel pretty isolated and private, right? But in networking terms, you're basically walking through a highly crowded public square. Who is actually watching your data as it leaves your device? Let's trace that path. When you browse normally, 5 things happen in a specific order. Picture your device on the left and the destination on the right. First, the DNS lookup. Your device asks your internet service provider for a website's IP address, and this is usually completely unencrypted. Second, connection setup opens a path straight through your ISP. Third, the TLS handshake kicks in to establish an encryption key, assuming the site uses HTTPS. Fourth, your scrambled request travels across public routers. And finally, the response returns along that exact same path. Now, you might be thinking, well, step 3 secured it. I've got HTTPS, I'm good. But here is the major catch. HTTPS encrypts the content of your conversation, sure, but the metadata, that is left completely exposed. Your ISP can't read the specific article you're reading, but they can definitely see your real IP address, the exact domain you are visiting, and the volume of data you're pulling down. So your digital footprint is still highly visible. Which brings us to Section 2, the VPN double envelope. Think of all this like the postal system. A normal internet connection is basically like mailing a sealed envelope. The post office can't read the letter inside, that's your HTTPS, but they can clearly read the destination address stamped right there on the outside. A VPN connection, on the other hand, acts like putting your sealed envelope inside a second, completely opaque envelope. You address this outer envelope to a trusted middleman, the VPN server. So your local post office only sees a package going to that middleman. They have absolutely no idea who the final recipient actually is. Let's run through those steps again, but with a VPN. Step 1, your device encrypts the entire original packet and tunnels it. Step 2, your ISP watches this travel by, but they only see that outer wrapper addressed to the VPN server's IP. Step 3, the VPN server receives it, decrypts the outer layer, and forwards your real request to the destination website using its own IP address. And Step 4, the website replies back to the VPN, which wraps it back up securely and tunnels it all the way home to you. All right, Section 3, who actually sees data? Now, what's really interesting about this next part is that it exposes the reality most explanations just skip right over. Let's break down the visibility trade-offs here. Without a VPN, your ISP sees both your real IP and your destination. But with a VPN turned on, your ISP only sees encrypted gibberish heading to some server. The middle networks only see the VPN communicating with the website, and the destination website only sees the VPN's IP address. But notice the VPN provider. They see your real IP, and they see the destination site. The fundamental truth of all this is that nobody outside the VPN provider sees both who you are and what you're doing at the exact same time. All that visibility is concentrated squarely inside the VPN server. And it is absolutely vital to remember this point. A VPN does not add encryption where none existed on the website side. HTTPS and VPN encryption are totally independent layers. They stack together nicely, but they do not replace each other. If you visit an older website that only uses plain HTTP, the VPN protects your data as far as the VPN server, but from that server to the actual website, your data is sent completely unencrypted. Moving into Section 4, deep dive into tunneling and DNS. Let's shift from the broad concepts and look at how this networking actually functions under the hood. The core mechanism making all of this magic possible is called tunneling. When you use protocols like WireGuard or OpenVPN, what they do is take your original packet, the headers, the destination, the payload, the whole shebang, and they treat it as cargo. They encrypt it and drop it into a brand new packet, which acts as a heavy-duty shipping container. Anyone watching the wire between you and the VPN server literally only sees this shipping container. And why is the IP address such a big deal in this process? Well, an IP address is essentially your device's digital street address. It's totally necessary for routing data, but it also reveals your rough geographic location, like your city or region, and it can be tied right back to your personal internet account. By substituting its own IP address for your real one, the VPN effectively changes your digital street address to wherever their server happens to be located in the world. So, the crucial point is how this affects DNS resolution. Remember earlier, DNS translates a human-readable name, like example.com, into a computer-readable IP. Normally, your ISP handles this in plain text, quietly building a massive, detailed list of every single site you visit. A properly configured VPN catches these DNS queries and forces them right through that encrypted tunnel to its own resolver. If your VPN doesn't do this properly, it causes what's called a DNS leak, and your ISP can still see your entire browsing history, even with the VPN turned on.
Okay, Section 5, Pros, Cons, and Myths. Let's compare these methods directly and bust some of that marketing hype.
Let's move on and see how this builds a clear picture of the trade-offs. Normal routing is direct. It's the absolute shortest path between point A and point B, meaning it's faster with much lower latency. The VPN connection, by definition, is a detour. It routes your traffic out of the way to a secondary server, which inherently adds latency and can drop your speed. You are directly trading performance for privacy. You get that masked IP and shielded local traffic, but for sure, it's at the cost of maximum network speed. We also really need to address some massive industry myths right now. First off, a VPN does not make you anonymous. No way. Websites can still track you using cookies, browser fingerprinting, and, your actual account logins. It also doesn't stop phishing or malware from tricking you. And as we've learned, consolidating all your traffic to one provider isn't inherently better security. It actually creates a single point of failure if that specific provider gets breached. And this brilliantly illustrates the ultimate truth of this entire explainer. A VPN shifts trust. It does not eliminate it. Without a VPN, you're placing your trust in your local internet service provider. With a VPN, you are fully trusting the VPN company. You are simply rerouting your data visibility from one corporate entity over to another. Let's bring it all home with Section 6, when to actually use a VPN. Let's ground this in practical reality. So, if you're on an untrusted public Wi-Fi network at a cafe, a hotel, or an airport, a VPN is incredibly useful to shield your data from local snooping. It is also an excellent tool if you specifically want to hide your browsing metadata from your ISP, if you need to appear to be in another country to bypass geographic content restrictions, or if you are securely tapping into a remote work network. In these specific scenarios, the trade-off in speed is absolutely worth it. Conversely, there are plenty of times it's just unnecessary. If you are browsing from home on your own password-protected network and visiting standard HTTPS websites, your content is already protected. Leaving a VPN on 24/7 at home might just be slowing down your connection for a very marginal privacy gain. And again, if you are actively logging into your personal Facebook or bank accounts, the VPN is not making you somehow invisible to those services. They still know exactly who you are. To summarize our main takeaways today, a normal connection is a fast, direct, unshielded path where your trust is scattered across your ISP and various middle networks. A VPN wraps that data in a protective tunnel, completely hiding your destination from your ISP and your identity from the website. But it requires a detoured path, and it concentrates all of your trust entirely onto one single VPN provider. Which brings us to the ultimate question that you have to answer for yourself. Privacy isn't really about being perfectly invisible. It's about deliberately choosing who holds your data. Based on everything we've uncovered today, when you route your digital life, who do you actually trust more? Your local internet service provider or the VPN company you're paying? Think carefully about the privacy policies and the incentive structures of the companies handling your traffic. Thanks so much for joining me on this explainer, and keep asking those tough questions about your digital footprint. Catch you next time.